Hey everyone, and welcome. Today, we are diving deep into statistics, which is honestly the secret language of the modern world. Seriously, whether you're looking at a business report, a scientific study, or even your favorite sports team's stats, data is everywhere, and it's always telling a story. So today, we're going to give you the keys to understand it, step by step. And I want to give a huge welcome to all the students joining us from Mathematics in the Modern World. I'm so glad you're here. My big goal today is to make this whole journey into data not just, easy to understand, but actually fun and exciting. So let's get right to it. First stop, your data adventure. And I'm not kidding when I call it that. Try not to think of this as just another math lesson, okay? Think of it more like you're getting a travel guide to explore the entire world through the incredible stories that numbers have to tell. So what even is statistics, anyway? Well, at its heart, it's the science of making sense of the world through data. It's this awesome, structured process that lets us take what looks like a chaotic jumble of numbers on a spreadsheet and turn it into a clear, powerful insight. And we can actually break this whole thing down into 6 key steps. A handy way to remember it is with the acronym COPAR. First, you collect your data. Simple enough. Then, you organize it so it's not a mess. Next, you present it, maybe in a cool chart or a graph. Then, the real fun begins. You analyze it to find patterns, you interpret what those patterns actually mean, and finally, you report what you found. That's it. That's your 6-step guide for any data adventure you go on. And this quote just says it all. Now, Bertrand Russell wasn't talking about literally being sad. What he meant was that behind every single column of numbers, there is a human story. A story of success, a failure, of discovery. And statistics? Well, that gives us the tools to finally read those stories. So as you go on this data journey, you're going to find there are pretty much 2 main paths you can take. You can either describe the world you see right in front of you, or you can use that info to make some really smart guesses about what you can't see. And that right there is the difference between describing and inferring. Think of it like this. Descriptive statistics is like taking a photo of the landscape right in front of you. You're just summarizing what you have, like calculating an average or making a bar chart. It's all about the here and now. Inferential statistics, though, that's like using the photo you took to predict what's over the next hill. You take a small piece of data and use it to make an educated guess, an inference about a much, much bigger group. Now, to make those kinds of predictions, you gotta have the right tools. And probably the most essential tools in your entire statistical toolkit are the ideas of a population and a sample. Okay, so the population is just everyone or everything you want to study. It's the whole shebang. If you want to know the average height of all college students in a country, then every single one of those students is your population.
But let's be real, trying to measure every single one of those students would be a total nightmare, right? It's practically impossible most of the time. So what do? We take a sample, a smaller, more manageable group that hopefully represents that whole population. So we might survey, say, 500 students to try and learn something about all 500,000 of them.
Now, that number we really want to know, that true, actual average height of all the students, that's called a parameter. Just think, P for parameter and P for population. This is our target, the true value we're chasing. And since we usually can't get that parameter directly, we calculate a statistic from our sample. So the average height of the 500 students in our sample is a statistic. And you can remember this one too, S for statistic and S for sample. It's our best guess at that true parameter. And this brings us to a super important idea, sampling error. I mean, think about it. Since our sample isn't the entire population, the average height we get from it is almost never going to be exactly the same as the true average. That natural little difference is called sampling error. And here's the most important thing to get. It is not a mistake. It's totally normal, it's expected, and it's just part of the deal when you use a sample. It's exactly why you see that margin of error in news polls. And hey, right here, I just want to pause for a second and say a massive thank you to everyone who's been supporting our class channel. No problem, only solution. Honestly, your support and your comments really do keep these explainers going. And if you're new here and you're getting something out of this, we'd absolutely love for you to join us. And that's really the big takeaway here. understanding all these fundamental ideas is what changes you from someone who just looks at a bunch of numbers into someone who can actually make data talk. You've got the foundation now, so the only question left is, what stories are you going to tell? I really hope this helped you build that foundation. And if you want to keep going, be sure to check out the Beyond 2025 Math in the Modern World playlist, where you can find all the explainers we've done on this subject. Thanks so much for watching, and I'll see you in the next one.